We are in section 7.6. This is the section that talks about double angle formulas and half angle formulas. I'm going to work example 4 with you, but before I do, I just want to back up and repeat some stuff I'm putting in your notes. You need to memorize A, which we have only one, sine double angle, and you need to memorize one of the double angles. What I've mentioned to you in your notes is to find them on here, and here's the double angle for sine, and then pick one of these, any one, for the cosine's double angle, and then memorize the tangent double angle. So that's what I'm saying when I'm writing. Memorize one of each, and whichever one you pick on the cosine, it's going to work. The same thing for the half angles. On the half angles, you have a sine and a cosine, and then pick one of the tangent half angles that they list. Now there are some other formulas which would be helpful to write down, where you have the sine squared theta, the cosine squared theta, and the tangent squared theta. And if you look on your formula card, you're going to see the sine squared and the cosine squared. You might want to write the tangent squared down here just to have it for future reference. But again, you got to memorize one of each of the double angles and one of each of the half angles for our next test that's coming up. You are going to get to use this formula card, but not on the Chapter 7 test. So you have those, and I mentioned the half angles, which are down on the bottom of this other page. And so I've already said memorize one of each of these, and the tangent gives you a couple of other versions, and so just pick the one that you like. And one last thing I want to say about the half angles before we go on. I know he mentioned it, but I like to highlight it, underline it, put a couple of exclamation marks with it, that when you're doing half angle, the way you know which sign you need, either positive or negative, is determined by what quadrant does the half angle lie in. Not what quadrant does alpha lie in, but which one the half angle lies in. So highlight it, underline it, make it a big deal in your notes and in your mind when you're calculating, or to help you when calculating the half angles. So the question, problem, the example that I want to work with you is example 4. And as we look at example 4, it asks us to solve an equation. So we've been doing a lot of stuff through the videos and through the examples dealing with half angles and with double angles. I'm asking you to memorize them because we talk in our department, and we talk to the Cal 1 and Cal 2, Cal 3 professors. And one thing that comes up is a lot of the information that you're getting in your upper level courses ties directly back into this course, and there are pieces and parts you have to remember. So the formula card's great, but you got to have a lot of this, not all of it, but a lot of it rolling around in your brain. Like when it says to solve this, I know I have a factor, but I can't set each factor equal to a negative 1/2. I'm supposed to set each factor equal to 0. That's not what I have. But if I have memorized these formulas, I see this sine and cosine and I think, man, that looks familiar. And then right here, if it was not just sine and cosine, if it had a 2 out front, I could substitute all of that for the double angle of sine. So I'm allowed to multiply both sides by 2 to make it what I want it to be. And so now this all becomes the double angle of sine, and this all becomes negative 1. This then directly relates back to what we were doing in our last section when we were talking about inverses and finding angles, because I was asking you a question. The sine of what ends up being negative 1? The sine of what ends up being negative 1? And I do want to go back here and point out, we're not doing all angles. We are restricted to be greater than or equal to 0 and less than 2 pi. But going back here, the sine of what gets us negative 1? Well, that's quadrantal. And quadrantals, sine negative 1 based on the y, not the x. And so when I'm looking for the y, my y of negative 1 is right there. I'll go 0 and negative 1. So what angle will get me the sine of what gets me negative 1? Well, that angle is a 3 pi over 2. But it's not just theta, it's that my 2 theta is that 3 pi over 2, but I have to keep in mind that it's not just 3 pi over 2. It's when I go back one or a couple of this way. Anyway, there will be more angles that also have the sign of -1, so I have to account for them using my 2k pi. But I don't want just 2 theta, I do want just theta. And so the trick we did on the other lesson was we divided by 2, and these are easy to divide by 2. But this other one, it's easier to see that the other way to divide by 2 is to multiply by the reciprocal. And so what that gives us is theta is 3 pi over 4 and, or plus, k pi. Once we have this, we're going to start trying different things for our k. We'll try -1, 0, 1, and 2. Those are like the normal ones we will try. When we pop out answers for theta, remember we have to have our theta between 0 and 2 pi. So for practice sake, I'm going to let k equal, well, I'll go ahead and start with a -1. Because when I start with a -1, I get that my theta is 3 pi over 4. And with a negative pi, that's a -4 pi over 4, and we bust out of the acceptable boundary. That gets us at -1 pi over 4, and that's too small, it's less than 0. So now let me try, let k equal 0. I like this one. Boom, it's gone. My theta is 3 pi over 4. So I'm going to go ahead and get me a solution set started, that 3 pi over 4 is an answer, but I could have more. So now I'm going to say let k equal 1. So when I put a 1 in here, my theta is 3 pi over 4 plus 1 pi. I'm going to go ahead and change it to the denominator I need, 4 pi over 4, and I get 7 pi over 4. And in my mind, that's 1 3/4 pi, so it's not quite 2. So we have another winner, 7 pi over 4. I got a really sneaky suspicion that that's going to be it, because when I go try let k equal 2, I'm going to bust through. Because when I let it be 2, my theta is 3 pi over 4 plus 2 pi. Well, 2 pi is my maximum. I can't go past it, and that'll put me over. So we are done. We have found what we need. Just to double check what it's asking, it says solve the equation. I always like to check with what they've got going on in the book. And when we look up here at the top at page 504, there we are. We got us a 3 pi over 4 and a 7 pi over 4. And those are the ones that we generated. This was example 4 in section 7.6.